Hello everybody, this is our fifth lecture in the International Economics course. In this lecture, we will complete Chapter 3, the Standard Theory of International Trade. The main points of this lecture are equilibrium in isolation, illustration of equilibrium in isolation, equilibrium relative commodity prices and comparative advantage, the basis for and the gains from trade with increasing costs, illustrations of the basis for and the gains from trade with increasing costs, equilibrium relative commodity prices with trade. Equilibrium in isolation. In the previous lecture, we discussed production frontiers, which illustrate the production or supply conditions in a nation. And we also explained community indifference curves, which reflect the tastes or demand preferences in a nation. Now, we will see how the interaction of these forces of demand and supply determines the equilibrium point or point of maximum social welfare in a nation in isolation. Isolation means absence of trade. In the absence of trade, a nation is in equilibrium when it reaches the highest indifference curve possible given its production frontier. This occurs at the point where a community indifference curve is tangent to the nation's production frontier. The common slope of the two curves at the tangency point gives the internal equilibrium relative commodity price in the nation and reflects the nation's comparative advantage. Illustration of equilibrium in isolation. The following figure brings together the production frontiers and the community indifference curves. We see in the figure that indifference curve 1 is the highest indifference curve that nation 1 can reach with its production frontier. Thus, nation 1 is in equilibrium or maximizes its welfare when it produces and consumes at point A in the absence of trade or autarky. Similarly, indifference curve 1' is the highest indifference curve that nation 2 can reach with its production frontier. Thus, nation 2 is in equilibrium at point A', where its production frontier is tangent to indifference curve 1'. Note that since community indifference curves are convex from the origin and drawn as non-intersecting, there is only one point of tangency or equilibrium. One such equilibrium point exists because there are an infinite number of indifference curves. Points on lower indifference curves are possible but wouldn't maximize the nation's welfare. The nation can't reach higher indifference curves with the resources and technology presently available. Equilibrium relative commodity prices and comparative advantage. The equilibrium relative commodity price in isolation is given by the slope of the common tangent to the nation's production frontier and the indifference curve at the autarky point of production and consumption. Thus, the equilibrium relative price of X in isolation is PA equal PX over PY equal 1 over 4 in nation 1 and PA dash equal PX over PY equal 4 in nation 2. Relative prices are different in the two nations because their production frontiers and the indifference curves differ in shape and location. Since in isolation PA is smaller than PA dash, therefore, nation 1 has a comparative advantage in commodity X and nation 2 in commodity Y. It follows that both nations can gain if nation 1 specializes in the production and the export of X in exchange for Y from nation 2. The forces of supply, which is the nation's production frontier, and the forces of demand, which is the nation's difference curve, together Determine the equilibrium relative commodity prices in each nation in autarky. If indifference curve 1 had been of a different shape, it would have been tangent to the production frontier at a different point, and would have determined a different relative price of X in nation 1. The same would be true for nation 2. Note that this is in contrast to the constant costs case, where the equilibrium Px over Py is constant in each nation, regardless of the level of output and the conditions of demand, and is given by the constant slope of the nation's production frontier. The basis for and the gains from trade with increasing costs. Note that a difference in relative commodity prices between two nations is a reflection of their comparative advantage and forms the basis for mutually beneficial trade. Accordingly, the nation with the lower relative price for a commodity has a comparative advantage in that commodity and a comparative disadvantage in the other commodity with respect to the second nation. As a result, each nation should specialize in the production of the commodity of its comparative advantage and exchange part of its output with the other nation for the commodity of its comparative disadvantage. However, as each nation specializes in producing the commodity of its comparative advantage, it incurs increasing opportunity costs. Specialization will continue until relative commodity prices in the two nations become equal at the level at which trade is in equilibrium. Then, by trading with each other, both nations end up consuming more than in the absence of trade. Illustrations of the basis for and the gains from trade with increasing costs. We have seen that in the absence of trade, the equilibrium relative price of X is PA equal 1 over 4 in nation 1 and PA dash equal 4 in nation 2. Thus, nation 1 has a comparative advantage in commodity X and nation 2 in commodity Y. Suppose that trade between the two nations becomes possible. Accordingly, nation 1 should now specialize in the production and the export of commodity X in exchange for commodity Y from nation 2. How this takes place is illustrated by the following figure. In the figure, starting from point A, which is the equilibrium point in isolation, as nation 1 specializes in the production of X and moves down its production frontier, it incurs increasing opportunity costs in the production of X, reflected in the increasing slope of its production frontier. On the other hand, starting from point A dash, as nation 2 specializes in the production of Y and moves upward along its production frontier, it incurs increasing opportunity costs in the production of Y, reflected in the decline in the slope of its production frontier. Specialization in production continues until relatively commodity prices become equal in the two nations. The common relative price with trade will be somewhere between the pre-trade relative prices of 1 over 4 and 4 at the level at which trade is balanced. In the figure, the common relative price is at point PP equal PP dash equal 1. Accordingly, with trade, nation 1 moves from point A down to point B in production by exchanging 60X for 60Y with nation 2. As a result, nation 1 ends up consuming at point E on its indifference curve 3. This is the highest level of satisfaction that nation 1 can reach with trade at Px over Py equal 1. Thus, nation 1 gains 20x and 20y from its no-trade equilibrium point. Similarly, nation 2 moves from point A dash up to point B dash in production, and by exchanging 60y for 60x with nation 1, it ends up consuming at point E dash on its indifference curve 3 dash. Thus, nation 2 also gains 20x and 20y from specialization in production and trade. Note that with specialization in production and trade, each nation can consume outside its production frontier. Equilibrium relative commodity prices with trade. The equilibrium relative commodity price with trade is the common relative price in both nations at which trade is balanced. At this relative price, the amount of X that nation 1 wants to export equals the amount of X that nation 2 wants to import. Similarly, the amount of Y that nation 2 wants to export exactly matches the amount of Y that nation 1 wants to import. Note that any other relative price couldn't persist because trade would be unbalanced. Let's take examples. At a relative price of X higher than 1, nation 1 would want to export more of X than nation 2 would be willing to import at this high price. As a result, the relative price of X would fall towards the equilibrium level of 1. Similarly, at a relative price of X lower than 1, nation 2 would want to import more of X than nation 1 would be willing to export at this low price. As a result, the relative price of X would rise towards the equilibrium level of 1. Thus, the relative price of X would gravitate towards the equilibrium price of 1. The same conclusion would be reached in terms of Y. Finally, once the equilibrium relative price with trade is determined, we will know exactly how the gains from trade are divided between the two nations, and our trade model will be complete. Note that in the previous figure, the equilibrium relative price of X with trade results in equal gains for nation 1 and nation 2, but this needn't be the case. Note also that if the pre-trade relative price had been the same in both nations, there would be no comparative advantage or disadvantage in either nation, and no specialization in production or mutually beneficial trade would take place.